Hello everyone and welcome again. So let's talk about disk space. Let's say we have 10 sims and each one of them is 100 megabytes. Okay, so that's 1 gigabyte per frame and we have about 250 frames. So that's 250 gigabytes for 10 sims, which is not the case. We have about 20, actually more, but let's say 500 gigabytes for one iteration. Okay, we're going to do way more than one iteration in a project. We're going to do probably 10 of those sims. We'll work on smaller bits of course, but we will need at least 5 terabytes for one sim to account for multiple versions. So we're talking about, to be safe, 6 terabytes. Maybe, no, we need 8 terabytes just to be safe, to iterate over destruction, do the EXRs. If we wanted to do deep render, if we wanted to do anything extra, we'll go with 8 terabytes. Okay, that's great. So let me write this down. Now, let's say on the render time for one frame is 30 minutes, or let's go 20 minutes. 20 minutes per frame, which is very conservative. For my case, it was a lot more. But we don't have one pass. We have a lot more passes. We have the geometry, the main geometry. We're going to have smoke, probably multiple smoke passes. We're going to have atmospherics. We're going to have sparks. So let's say we have 10 passes. Okay, so 20 minutes multiplied by 10, 200 minutes per frame. Divide that by 60, that's 3 hours per frame. Let's round it. 3 hours per frame. And we have about 250. So 3 multiplied by 250, so 750 hours. Divide by 24, that's 31 days of rendering. Now I'm talking about dual Xeon's time here. I'm not talking about the normal CPUs. If we were to be using normal CPUs, we would be doing this. So with dual Xeons, let's say we get a 48 cores machine, multiply that by 2.3 gigahertz. Okay, so let's do the math. This is 31 days. So let's do total render time. 31 days. And this is on a 48 cores machine. So to make this 31 days be less, we need 10 machines, 10 render nodes to make that render in 3 days. Okay, so we need to split. We need to multiply the render nodes, get it done in 3 days. Perfect. That's very, very good option. But now let's compare the normal CPUs. We have 48 cores at 3.2. Okay, 48 at 3.2. That's 110 gigabytes. Now we get those i7s or whatever, the gaming stuff. And we have 8 cores at 4 gigahertz. So that's 32 gigahertz total. There's about difference of 3 times. It's going to be more, but let's say 3 times. So instead of 31 days, you actually need 91 days or 93 days. Let's say 90 days with one machine rendering. Pardon me. And to make that work less or get it done faster, we need, let's say, 10 nodes. That's 90 days. We need 30 nodes to get it done in the same time. Okay, so I don't have any of this. Okay, I don't have any hardware. I need to be able to do this. I need to be able to have 10 render nodes and render all of this in 10 days. Well, if you're working for a client, you should be able to afford that. So what our studio does, what Rebel Way, when we work in VFX, we rent. I'm lucky enough to be in LA. They have a very good place that we can rent hardware from, and I'm going to show it. I'm going to show the numbers, and then I'm going to show what it actually means to buy this, whether with Xeons or AMD in the next video. Okay, so we need 10 nodes. That's it. I'm gonna go to American Computer and Engineering. They are they work for VFX. So this company rents nodes and sells nodes, and I get stuff from them. So whether you need multi-GPU, RAID storage, actually let's take a look at the storage. So we talked about 8 terabytes. They have a lot more. So they have a lot more capacity if you need that. But we can get this 24 terabytes for 1 month. We work on the project and then buy one or two drives of 4 terabytes each, or one for 8 terabytes, and let's do the math, and then cache everything. So not this one. So okay, so let's quickly talk about the hardware. Let's say we need a render, we need a blade. Pardon me. We're gonna rent that 24. That's going to be 790. Let's say 800, and then we need about 200 to cache. I'll explain why. So 1K just for rental 1 month. The 200 I'm gonna buy an Iron Wolf 8 terabytes with and cache the latest version of everything. I'm not gonna cache everything. I'm not gonna cache the 8 terabytes. This so that when the client comes back, I can still go back to that project and use it. I'll go to 400 just to be safe. So 1.2K hard drive. So we need 10 nodes. Let's see. I'm gonna go home, render nodes, and they have 2 options. This is very advanced. This is if you have a server, you have a case, you can plug it in and needs special cooling, and it's more for studios. So if you want to go that route, they have each node. So this is a 4 node. So you have 4 CPUs, 4 computers in this node. Okay. And each one of them has 2 Skylakes, has 2 CPUs. You can see the CPU power here. Okay. So we can rent one of these, which is pretty good. You have 8 cores, 8 CPUs. So let's do the math. I'm gonna go with the smallest one first. So we did the calculation based on 110 gigabytes and gigahertz, and we actually need this much power. By 10 nodes, I need 1100 gigahertz. So this one, let me open the calc. I hope you guys find this interesting. So we have 8 cores multiplied by 8. That's 64 CPUs, or 64 cores multiplied by 2.1. 8 multiply by 8 multiply by 2. So 128 gigahertz. This is quite low. No. I think, yeah, this is... So 8 multiplied by... Yeah, 4 nodes, 8. That's correct. Multiply by 2. So each node has 128 gigahertz. Okay? We need more than that. We need 10 of these. Okay? So if we want to go with this route, it's 9,000 to rent them for 1 month. 9K. Okay, so this is for studios, for professionals. I don't have this. We don't have access to host these servers. So what I get instead is workstations, and this is something you can work on. So if you're an artist, this is a great option. So let's go. So with these, you will get 2 CPUs on each one. Okay, I'm gonna go with the most expensive one, the 24 cores, 2.7 gigahertz. It's better to get these 2 and pay for the price versus having a cheaper one and a smaller price. Okay, so let's go with the expensive one. Let's say it's 1,000. Okay, I'm gonna say 24 cores multiplied by 2 multiplied by 2.7. This is great. And then I can multiply this by 10 I have approximately what I need, and it's the same ratio. I'm gonna rent 10 workstations, and it's 1,000 each. That's 10k. So we have another 10k for 1 month. That's it. You're gonna rent them for 1 month. Well, you don't need them, but the minimum is 1 month. We could go with less than this, so we could rent only 5 workstations and finish this in 6 days, which is not bad, but let's say we need 6k hardware for 1 month. Okay, so this is for the hardware. Now for the licenses. These 10 nodes, or 5 nodes, we're gonna get 5 nodes. We need Arnold licenses. So 600 each, 0.6, that's 3k Arnold. Okay, and then we need Houdini. For Houdini, we only need the render engine. We don't need the full license, and that's 0.7k, so $700 for the render license. It's a floating license, so we can use it on any machine. We need 5 of them. So that's 3.5k. So 6 plus 3 plus 3.5, that's 12.5k just hardware to be able to do this in a reasonable amount of time with the software and hardware you need. So this is some numbers for you guys to think about, which is reasonable because that hardware is a lot more expensive. If you wanted to buy this 24 cores, it's actually $14,000. Okay, and it's 48 cores. Each one is 24, and this one is $8,000. So if you wanted to buy 10, that's $80,000. Okay, so for the other way is to get look into AMD. This is all Xeon stuff. Okay, and for AMD, we have few options. They're not cheap. They seem cheap, but they're not cheap. So we have the 2990WX, and then we have AMD 2970X, and I believe 6, and then the new ones. So 3990X, this is 4K, just the CPU, and then we have, I believe, this, which is 2K for the CPU, and then we have 2K USD, and then this, I believe, 7, which is 1K or 1.2K, and then 3960, which is 0.6, and it goes like this. It goes 64 cores at 2.3. I'm not sure, but something like that. This one goes 32 multiplied by 3 gigahertz, I believe, or 3.2. Go for the higher. And then this one has 24 cores at 3.6, and this one has 16 cores. We'll go at 4. So let's do the math for each one of these. So 64 multiplied by 2.3, that's 774. Very good. And then 32 multiplied by 3.2, it's 102. And this allows you quickly to understand how fast each CPU is going to be compared to the other one. So you can do the math, and it's not going to be correct for sims and things like that, but it will be correct for renders all the time. So 24 cores multiplied by 3.6, it's 85, it's 200, and then this one is going to be 16 multiplied by 4, 64. I'll do 60 just to round it. I think it's slower. Okay, so that's the ratio. We need 1100. So we need either 5 of these, 10 of these, 10 of these, or 20 of these. And these ones, they're not cheap. This one is 4K CPU, this one is 2K CPU, and let's say you're gonna build this. Okay, let's say we go with this one. We need 10 nodes. It's 2K for CPU plus 500 for motherboard, 500 for memory, plus 500 for case, PSU, and things like that. So 500, 500, 500 plus 2000. That's 3.5K minimum per workstation. If you're gonna buy 10, that's 35K plus the hardware, the cost of licenses and everything. So even if you go with AMD, it's not gonna be that cheap. It's still going to be costly. Now, this I didn't include sim time at all. I only included render time. Sim time, we're going to need similar power for at least 2 months, not just one, because they're going to be slower. You cannot, the only problem with sim, you cannot distribute them. I mean, you can cluster them manually, but it's not like rendering a sequence where each node is going to get a frame, do the same thing, and done. With sim, you have to wait for the first frame, to finish the last frame, you have to wait for all the frames to finish, not like the render. So even if you have 100 machines, you're not going to be able to use all of them for sims. So you need at least 4 workstations for 2 months to provide that capacity. And this is what it would look like in terms of numbers. And I wanted to make sure that you guys are aware that this stuff is not cheap. It's going to cost a lot of money if you wanted to work from home or start your own studio or just rent. It's going to be expensive. Now, other solutions would be, I believe, cloud. Amazon has something. I haven't tested. Igor did, and then there's another one. I can't remember now. They offer Houdini Sims. The Grid Market. So Grid Market, guys, they have online nodes that you can rent. You can submit jobs and rent. But the thing with that is that when you submit a sim online, it stays online. You cannot work on it locally. So you have to do a lot of you have to download one frame, one cache, and then test it. It's not ideal. And it's also very expensive. If you do the math, if you try and submit a job, it's probably going to be more expensive than this. Maybe less, maybe similar, especially with the license price and stuff. And another very important thing is electricity. Electricity can be anywhere from 200, I don't know, depending on where you live, to 600 if you run all these nodes for 1 month. Okay, so it's going to be a lot of heat. It's going to be a lot of electricity that you have to pay for, and it's just a lot of compute power. Now, what I recommend doing is, because this is too expensive, accessible only to production stuff and people who can afford it, you can do stuff with normal equipment. So let's say, I'm gonna Google something super quick. I'm gonna show, 1 second. So this. So I have this this river here that is 5 years old. It's probably more, 6 years old, and I've done this on an i7 that is 10 years old at home. And you can see I have high-res sims, high-res everything, trees. It's fully fledged. The only thing is the render was low-res. I was only able to render 960 by 540, but it still looks good. It's not gonna deteriorate the quality of the work. This one we did using only 2 machines, 2 i7 machines. I only had 1, Igor had 2, and we did the same render everything on those 2 machines, and it still looks good. The only thing is the resolution. We couldn't afford to render, HD or 1280. So key is always lower the resolution. 960 by 540, something looks really nice, and it doesn't have to have a huge amount of resolution. It will look good at that resolution. For sims, my recommendation is to always have 2 workstations. Not just for sims, for doing effects. If you want to do effects, you have to have 2 workstations. They can be i7. You can get them from eBay for $500 each, have 64 gigabytes on them, DDR3, perfect. You work on one, and then when you have something, you test, you like it, you send it to the second machine, and you continue working. Okay, you don't pause. That's the key. You have something on the background cooking, doing something for you. That's how you can make progress. If you're gonna have just one machine, that's gonna slow you down. Now the other thing, if you work full-time, you only have a small amount of time at night, and depending on how your setup is, if you have your computer in your room, my recommendation is to work when you have time, and then submit whatever you have. Doesn't matter what. Always submit a sim. Every night submit a sim, take some notes, and do a preview of it. And that will allow you to make progress. You go to work in the morning, you come back, the sim is done. Just make sure you have enough memory and you have enough disk space. Those are the 2 requirements, and you can make a lot of good stuff with just small equipments. It doesn't have to be this expensive. But if you wanted to do more advanced stuff, this is the real numbers. This is what production pays. This is what you will need to do high quality work. Thank you so much for watching, and I hope that you guys found this useful. Talk to you soon. Bye bye.